Hello, everyone, this is Bradley. Today we're going to talk about this animation. And this animation is inspired by two questions, each asked by a different people. So one question was asking about this similar kind of animation done in Houdini. It was originally for kind of bank card advertisement, I think. And the second question is the person has the logo and he would like to animate each element differently. So I combined these two questions together to make this particular tutorial because originally I made one animation and made a tutorial. I think it's not a very good example. So today we're going to do this kind of complicated stuff. This tutorial will be intentionally separated into two parts so that we can answer two questions separately. So the first part essentially is the animation. The second part is how to get the texture onto it. The reason I'm using animation nodes is that dealing with such kind of complex eevee, you only can do with animation nodes instead of geometry nodes. I'm not sure about the Superchalk, maybe possible, I'm not sure. And I'm going to use the preset from my preset library. The link is provided in the description, which you can download for free. So let's start. When doing this kind of animation, you always go backwards or think backwards. You need to have the end results on your hand first and then to think about how to mess that up. It's like you're animating a logo, so you need to have your logo design perfectly and then start to think how to animate your logo. In this case, I'm just going to Control A and search for Hexagon and finally mesh object output. Connect the blue to blue and hit this circle and hit this plus icon and generate a hexagon. You can control the sides. I do not recommend you to control the radius because we need a hexagon. Next thing is just to duplicate this into a hexagonal grid. I'm going to use the transform mesh and distribute hexagon grid. So let's just say distribute hexagon grid. This is a new node since 2.93. If you do not have that, you probably need to update your animation nodes. So once we have this, we just to change the value. I'm going to change the type into step and change the XY size into 111. And then you can get different XY division as you like. The amount does not really matter. I will keep that quite low at this moment because I do not want to impact any performance as we go more complex at this stage. Since everything is procedural, probably do not worry about all this kind of parameter at this moment. So next step, just to know that this does not look like very well. So you just decrease the auto radius a little bit so that you see all this kind of honeycomb pattern. Next thing is we need to mess up this setup. So now everything looks kind of regular, perfect. Imagine that we have a texture mapping on it. Oh, it looks nice. But we need to break up all this kind of hexagonal grid. And to do that, the first step is I want to lifting all this kind of hexagon grid up. And then to decide, some of the grid goes to that direction, some of the grid goes to that direction, that direction, that direction. Okay, so the first step is lifting up with different magnitude. Here I want you to notice that we started with a single hexagon grid and then we are putting all this kind of grid or duplicating this grid onto each matrices. Matrices is basically a combination of location, rotation, and scale. So this is basically comparable to the point concept within geometry nodes. So which also means if we would like to animate these hexagon units, we need to manipulate these matrices. There are many different ways that we can manipulate matrices, including a node which is called offset matrices. So with this location enabled, if we lift it up, it's lifted up. And by changing this fold, we can determine the magnitude of how it has been lifted up or not, since our translation is this. So there are many different ways to make it randomness or other things. Here I'm probably just choosing this random fold. And by changing the seeds, you can get different seeds. So this part is just procedural and whatever. Next thing I want you to notice is by animating this translation, then we are animating the magnitude. So this is basically the first step of our breaking down of this entire animation. Everything has been lifted up. So here, in order to animate that, I'm going to use a particular node which is called animate vector, and I'm going to change the end value to 5 or whatever values and putting this result into place. So by changing this time, we're getting this animation, and by duration we basically define the interval of these keyframes. So this is kind of a procedure. You can determine the times that you need. So by changing these times into 30s, everything being animated, and there's no more animation after the 30. So currently I will just keep this as it is. And the next step that we will discuss is the second part of the animation is, as I said, is to make all this kind of different object fly to a different direction. So we need to make such kind of decision, and basically a random decision for each hexagon to fly to different places. In this case, I'm going to use the loop because I think this is kind of easier to understand. Another reason is that there is a node which is called a switch node, cannot take the plural in its condition. So if you take the Boolean list, so create a Boolean list, you cannot, it does not accept a list at this moment. So this is always a moment that you need to have a loop. So to enable a loop, you just select the node, hit W, and it goes to right. So you loop through matrices. So now you created a loop. Here we have the all this kind of loop, but I don't think I need to really work on the matrix within the loop, because I think I'm going to keep continuing to use this offset matrix, which works on plural. You can definitely make it move, works on singular by hitting U and disable this use matrix list. But I think, yeah, I don't like it. So I think whatever. Another reason I would like not to use this matrix is because I made a random Boolean node which works outside the loop. So basically what I do is just to put matrices into generic rest. It will output all this kind of yes, no, true, false. And we can put this result into the condition within the loop. So in this case, I think I'm just going to hit this cross to eliminate this matrix, and I'm going to hit this plus icon. The iterator, I'm going to use the Boolean list. The Boolean is basically yes, no checkbox. So this is called a Boolean. So put these Booleans into the conditions and to connect our result, which is yellow to yellow. So you do not need to worry about the count because everything is automatically generated once you connect the matrices into generic rest. So here is basically our Boolean list being generated, and then you can change the seeds, which basically switch between true and false. It's completely random. I do not recommend you to touch the threshold at this stage, just to keep that as default 0.5. Okay, so once we have this switch, basically what we want to switch is if this hexagon goes to Y or X. Basically this is the decision that we want to make. So here I'm going to take a combined vector and another combined vector. So here let's take a float input. This float input is just to hold the value for the moment. For example, if I just want to say that I have two combined vector, but the one has value on X, the other one has a value on Y. This means based on this Boolean, if it's true, then you move on X. If it's false, you move on Y. And we're going to create another switch because I want to make a second animation. So once this hexagon grid is moving on Y-axis, I want the second part to must move on X-axis. So this is very important. Okay. Here we're going to use the same Boolean. So if first time is true, then second time it must be false. If the first time is false, then the second time must be true. So basically doing the same combined vector things with our true and false. Up to this moment, it might be a little bit confusing about what kind of animation have you just done. So here, in order to make your life a little bit easier, let's just hit this plus icon and we're going to output a vector list. So the vector list taking whatever outputs, so you take one output. Because we will combine these two different outputs later. You don't need to worry at this moment. So once we have this vector list, I'm going to just use the offset matrices. So here, let's expand our node tree a little bit and take these offset matrices and connect blue to blue. So immediately we do not see anything yet, but if we try to change this float input, then you can see the, some hexagon grid goes to positive y, some hexagon grid goes to positive x. So this is basically the difference at this moment. Here, this is currently a little bit very boring because everything just goes to positive. What if I want some of them goes to negative? So there are many different approach. And another important thing is they're basically going with the same magnitude. So do you realize that? If I ask them to move 10, everything just move 10. So I want to give the different positivity. So basically I need a float math and times that to a different number. So in this case, if I'm within the loop, then I'm going to hit this minimum maximum loop. I've talked about this preset in the past in a separate tutorial. So here, let's just move this up later. Okay. So in this case, let's just put the indexes to the seed. Actually, I'm going to call another preset which is called index seed. I think very soon I'm going to make a tutorial specifically talking about this index seed preset. But currently you just need to put the seed into parameter or just change everything within the seed. So, and we put the values into the B. So I think I'm going to use the absolute range and take the base to 0. And then increase these values. So absolute range means there's no percentage. If you hit 1, then it goes to positive 1 and negative 1. If you hit 2, positive 2 and negative 2. So this is how random value being generated. So in this case, this is how it works. So now I want you to know. So now this is kind of distributed positive y, negative y, positive x, negative x. Yes. And this float input determines the animation. And as previously we animate everything using animate vector, this time since we're working with a float, so we obviously should use animate float instead. So you take the results to replace our float input. And here the time, duration, everything is still the same, which means if this time hits to 20, which hits to duration, it should have animation. It does not have animation because we didn't change the value. So just type in 15 and type 20. So when it hits 20, animation stops. So this is how it works. So you can tweak a lot of things, but basically this is how it works at this moment. Here, one thing you need to realize is our animation about this kind of separation must occur after our lifting up. This is how I designed this animation. So usually if you would like to animate this vector, you use a node which is called time info. So the time info basically tells you the current frame. For example, if I'm on the frame 31, it tells the 31. And this animate vector, the time outputs, will offset with the duration. So this time, this new time is being offsetted, which actually means if you plug this, you push this, you click this positive and take the float. You can take this float as the new time to feed into our new animated float. and we can rename that as time so that you know what this float is for. The reason I'm doing this offset, the reason I'm using this offset at the time instead of original time info frame is because it's lifted up and then it starts to animate in the way we want. And this is why I need that. You can type in, change the value a little bit. So this is how it works. You can definitely change the seed so that change a different value. But this is how it works at this moment. And the next step is we're going to do the same with our second switch. Previously we made one switch, we need a second switch. How do we connect these two switches together? We simply use vector math and to add the values. And the rest of parts, most parts basically stay the same. Like we need this math. One math connected to X, one math connected to Y. Keep this multiply. Use animate float. Put the offset time into time. Put the same values. Minimum, maximum. We're going to duplicate as well. But this time we're going to use a second seed, basically a different seed, and put the value into the value. So now we can actually look about how this animation goes in general. So move upwards, move. Okay, so now this is how things looks. You can definitely change the seeds so that it looks kind of different, more interesting, or whatever. Basically, the animation looks more interesting if you have more randomness. But now there's one kind of randomness that we don't have at this moment is the randomness in time, because every animation start and stop at the same time, which is quite boring. To solve it, however, is kind of pretty simple. First thing I'm thinking is that I want to have a different magnitude. So minimum, maximum, list. If we are also, so basically I've explained this minimum, maximum, loop, and the list. If you're working within the loop, you use the loop version. If you work outside the loop, you use the list version. And you put these matrices into iterations. It will automatically connect them with the get list length, and then take these values into the duration. The base value is the base, and then it's percentage up and down. Although it says percentage range, but if it shows 0.5, it actually means 50%. So we can actually just preview the first part of animation. The duration, let's just hit that one. You can see some of the stuff already start to move on X and Y. Some of the hexagon is still trying to lift it up. It might not be very obvious, but anyway, it doesn't really matter. So you can also change the seed. 1.5. And we're basically doing the same repetitively using different minimum, maximum loop, different seeds, different values, 20s. Put the base into the parameter so that, let's talk about duration. Disable this absolute range. Take a different index seeds. Have a different offsets. Basically plug this seed into the parameter. where's our animate float? Yeah, this first animated float is actually there. So this is kind of confusing, but whatever. So once we have done these changes, we can play our animations. So you can see some of them, they finish the animation, but the others still moving. So all this kind of randomness, collectively speaking, they becomes, it makes the animation more interesting. One thing that's another thing I realized is this kind of animation is more kind of robotic. It's very hard. There's no very smooth transition. So you can just use this sigmoidal curve within the animate node. So take the float into the parameter. Everything to parameter. And change that to the sinusoid. Oh, there's one issue I actually found out, because you can see these times has been changed into time. This is a issue that you need to resolve. So within this iterator, let's take a float list. So anytime if you see these get list elements, it means something's wrong. You probably do not want to see that node any times. So here, instead of using time, I'm going to use the float, the iterator time. So that I think the animation should looks more. Yes, I think this is how it should looks. Yeah, I think this is already kind of good. It might the node tree may looks kind of horrible, but if you get it, if you understand every steps that you are doing, then this shouldn't be a very big deal. It's basically just a repetition about all this kind of different connection. We have multiple minimax loop, multiple minimax loop, multiple animated float, index seed, and multiple maths. Just it shouldn't be too difficult actually. Okay, once you have this being done, we can start to make it more complex. For example, increase the x divisions, increase the y division. Because this is generally a procedural step, so you can increase the amount, and everything will just be kept procedural. It definitely will delay the viewport a little bit, but the animation is there and being interesting. Just to know a fact that now the animation is going backwards, but I would like to reverse this animation. So originally everything is broken up and then reformed kind of pattern. So in this case, let's just reduce that a little bit, because my computer turns a little bit heavy actually. Okay, so in this case, let's just hit Control H to expose all these kind of hidden settings. So it tells the start frame, and let's just map range. And originally start frame is the minimum, end frame is the maximum. But let's the end frame mapped into the minimum, and the start frame mapped up into the maximum. So by doing so, we'll reverse this entire animation. You see? This is how this animation will finally goes. So I think this is kind of interesting. You can tweak a little bit more. So I think the first part of the tutorial will be just finished here, and we will move on to the second part about how to actually get our texture into the place. So I hope you enjoyed this tutorial, and I'll probably see you next time. Bye bye.